Hello everyone. In today's video, let us see some latest trends of questions that is being asked in JEE Advanced these days. For this video, I have chosen the topic permutation and combination, and we'll see some fast techniques to solve the questions of permutation and combination in relatively very lesser number of steps. So for that, let's see the first question of this video. This question is really amazing. This question has actually been asked in just previous year JEE Advance. The question says, in how many ways a person visit his office? The sentence of the question is a little bit modified. In how many ways a person can visit his office on exactly 4 days in lockdown period from I have chosen the data according to my own will. So 10 December to 25 December, such that no two visiting days are consecutive. Okay, the question is more or less same, not exactly same. And we have to answer this question. There are two possible methods. The popular method is, in fact, that strikes any student for the first time is you can use a multinomial theorem for solving this question. If you have not explored the mathematics in much depth, then you have to apply multinomial theorem, and then from there you have to find the coefficient of x to the power 12, and that method you can easily practice at your home. But that is not the best way to solve this question, because that method is going to consume so many space and time you won't get in your exam hall. Let us see the best method, that is method number 2. And in this method, I am going to use a very fast technique to solve the same question. And for that, let us say that these are the dates, possible dates on which the person can visit his office, right? From 10, 11, 12, 13 up to 25. So total number of available days on which he can visit the office is equal to, as you can see, is equal to 16, right? From 10 December to 15 December, including both 10 and 20, sorry, 10 to 25 December, including both 10 and 25. Now, as you can see, suppose that the person visits the office on the dates x1, x2, x3 and x4, right? His first visit, let us say, denote the first visit date as x1, second visit date as x2, third visit date as x3 and fourth visit date as x4, right? So let us assume this. So if I take these dates out of those possible dates, then let us say that the remaining dates on which he is not visiting the office are, let's say these days are like y1, y2, y3 and so on, y12, because there are total 16 days available to visit the office, and we just took out 4 days on which he visited the office. So remaining days, let's say these are y1, y2, y3 and so on, y12, right? Now, as you can see that among all these days, y1 to y12, x1, x2, x3, x4 can be anywhere in this cube, and so as we can see, yes, the main part of the solution is this. The concept is that we have to insert these 4 x1, x2, x3 and x4 among the gaps of the cube, Let's say that I inserted x1 right after y1, x2 right after y2, x3 right after y3. Then the person is visiting the office on the 2nd, 4th and 6th day and so on. So let us choose 4 possible, any 4 gap out of the gaps that is created by this queue. So as you can see that number of available gaps from y1 to y12 is equal to how many? As you can see, there are 2 gaps at the both ends and 11 gaps in between. So total gap equal to 13, right? So there are 13 gaps, and we have to choose only 4, any 4 gap out of the 13 gap. And Let us insert x1, x2, x3 and x4. There is only one way to insert x1, x2, x3, x4 because the first date of visiting has to be on the leftmost side and the last on the rightmost side. So there is no arrangement different from there is no any different arrangement possible. So the only way is 13c4, right? So only 13c4. So this is the correct answer. Just choose any 4 gaps, right? Let us quickly move on to the second question. It is saying that a 2 by 10 rectangle has to be tiled with 2 by 1 tiles. In how many ways this can be done? This question is a gem. I'm telling you why. Because the size of the rectangle is 2 by 10. That is, height of the rectangle is 2, length is 10. And the tiles themselves are of rectangular sizes. And the dimension of the tile is height is 2 and the length is the horizontal length is 1 and the vertical length is 2. Or in any way you can just rotate also, and you can fill the rectangle with these tiles. So in how many ways? Obviously we need 10 such tiles to cover the rectangle completely. So let us say n denotes the number of ways of tiling. I'm just generalizing it for the sake of convenience. I'm just generalizing it. Let us say the dimension of the rectangle is 2 by n instead of 2 by 10, 2 by n, and if you put n equal to 10, that will give the answer of our question, right? And the rectangles, the size of the tile is 2 by 1 tiles, right? So if n denotes the number of ways of tiling 2 by n rectangles, then what do you think? If n is equal to 1, which means that if we have the size of rectangle as 2 by 1, and as we see the size of tile is also 2 by 1, so there is only one way to fill the rectangle with tile. So a1 is equal to 1. So this is rectangle and this is tile. So just put the tile on the rectangle and the rectangle is covered with the tile. So a1 is equal to 1, right? Which means we have 2 by 1 rectangle and 2 by 1 tile also. Similarly a2 means 2 by 2 rectangle, and 2 by 2 rectangle, as you can see, can be filled with 2 ways. One way is putting the tiles horizontally as this, first tile and second tile, or you can say putting the tile vertically as this, in this, as you can see I'm drawing. So second way is this, your first tile and your second tile, right? Okay, now think about if we have the dimension of rectangle is 2 by 3. For that, number of ways should be a3. Okay, so we have to find the value of a3. How we can find it? So for finding the value of a3, that is number of ways of tiling 2 by 3 rectangle with 2 by 1 tiles. So instead of an, let us first find a3. Okay, so a3. See, there are actually 3 possibilities. The first possibility is, as I'm drawing here, if first tile is vertical, then other two has to be horizontal, right? Second possibility is all the tiles can be vertical, or you can say if the first 2 tiles are horizontal, then third tile is vertical, and the third possibility is all tiles has to be vertical. So as you can see, there are 3 possibilities. If the size of rectangle is 2 by 3 and the corresponding number of ways, I'm denoting it by a3. So a3 must be equal to 3 because there are 3 possible ways to tile a 2 by 3 rectangle with 2 by 1 tiles, right? Now, so these were the initial conditions that I was using. That suppose in case if we have to tile the rectangle of size 2 by 10, so 10 was weighing heavily actually, so that's why I reduced the dimension. Let us say that I have a 2 by n rectangle and I have to cover this rectangle completely with the tile of dimension 2 by 1. Let us say n is equal to number of ways. Now suppose while we are going to start covering the rectangle with tiles, let us say that the first tile of covering this 2 by n rectangle, let's say the first tile I'm putting is vertical, right? that is 2 by 1. Then we have the remaining dimension of the rectangle is 2 by n minus 1. Vertical height is 2, horizontal is minus 1, and the corresponding number of ways is a n minus 1, right? So if the first tile is vertical, then we have a n minus 1 number of ways to cover the rectangle with tiles. And if first tile, or you can say if the first two tile is horizontal, then the remaining dimension of rectangle is 2 by n minus 2, right? And the corresponding number of ways of tiling is nothing but a n minus 2. Okay, in the first case it was a n minus 1, in the second case it is a n minus 2. Okay, so total number of ways of tiling 2 by n. This is your first 2 by 1, 2 by 1, 2 by 1, and this is your 2 by n. Fine. Okay, yes, this is n. So total number of ways of tiling 2 by n rectangle with 2 by 1 tiles is equal to number of ways of tiling 2 by n minus 1, that is a n minus 1, plus 2 by n minus 2, that is a n minus 2. And the initial conditions are a1 equal to 1, a2 equal to 2, a3 equal to 3, right? And this is true for n greater than equal to 3 actually. Okay, so let me correct it. It should be n greater than equal to 3. So this is your relation between an minus 1 and an minus 2. And now let us use this formula. So what should be, as a1 is equal to 1, a2 is equal to 2, a3 is equal to 3. So what should be a4? That is tiling a 2 by 4 rectangle, that is a3 plus a2, putting n equal to 4 in the recursive formula above, and we are getting 3 plus 2, that is 5. So a4 is equal to 5. Similarly, a5 means covering 2 by 5 rectangle with 2 by 1, so a3 plus a4, and that is equal to 3 plus 5, that is going to be 8. And using this formula again and again, so you are getting a6. And now it should be 100% clear to you that using this technique, even if we are given 2 by n, where n can be any natural number, then using this technique we can easily find the number of ways of tiling the rectangle. And since in this case we are given 2 by 10, so calculating this with simple addition, we learned this in our nursery class. So as you can see, a9 is equal to 34 plus 21, that is 55, and this is going to give our answer a10, that is 2 by 10 rectangle, that is a9 plus 8. I hope this is clear to each and every one of you, and the concept that I have used in this particular question of solving this particular question, I have tried to make the solution as easy as possible to understand to all the students, right? So that it should be applicable in any other question also. Whenever you get some lengthy question, or you feel the question is really lengthy, that it is not striking even how to start the question, for that we should start with the smaller numbers. Like in this case, I started with 2 by 1, then 2 by 2, then 2 by 3. Yes, the concept I have used in this solution is called recurrence relation. And yes, this is a technique I think most of you who are also a student of computer science in your 12th class, you can appreciate this question, this solution in a much better way. Okay, I hope that you must have learned this gap method of solving the question. This is really a wow method, indeed a wow method. And then what I did there is recursive relation of solving. This was called initial condition. So you must have the initial condition whenever you are solving any recurrent relation, recurrent equation. Okay.